We once again would like to apologize for yesterday that there were 2 speakers that were not offered the opportunity because of unforeseen circumstances and time restraints. With that being said, we're going to give an opportunity to one of the speakers from yesterday session, the last session, which was about sharing recent development in building space capabilities. I would like to call upon the moderator for yesterday, Mr. Kaiser Moroka, the Deputy Director of Space Systems, to introduce our speaker from yesterday. Thank you, sir.
Morning once more. Thank you, Program Director. Yesterday we had Sansa as our last speaker. Let me remind you, just before I remind you of yesterday's presenters, I must thank Brian for setting the scene for October 4th to 10th. This year, World Space Week theme, space and entrepreneurship. I thank you, Dragonfly. KwaZulu-Natal yesterday made an appeal through word of mouth, looking for a very good engineer, as a reminder. Space Weather, they are servicing us 24/7, providing solutions to our services so that when they interrupt, at least we know what to mitigate the interruptions due to sun or space weather. So they also made a case yesterday to say we are here to provide solutions so that when you launch your satellites, at least you should know the conditions of space out there. When you navigate around, when you fly, you should know if there are some interferences. CPUT, they made a case that they are building mission to mission. So let's help them build that together. We are in this together. I hope the CPUT will also make use of Christos affordable test platform that he shared with us. We need those balloons in order to test some of the stuff that we are building. There's a saying that if we want to go fast, go alone. But if we want to go far, let's go together. I think this is what we are doing in this gathering. I thank you, ladies and gentlemen. Let's give a round of applause for Tebogo Mokhalagadi. Developing national space capabilities. Thank you. Over to you.
Good morning, everybody. I'm sorry for what happened yesterday. I had a medical emergency, so I had to run. But at least today I'm better. And I'm also happy to be provided with the opportunity to present what I was supposed to present yesterday. Okay. Down. Okay, the content of my presentation, I'll first start by going through a brief summary of the space engineering mandate specifically, as is an enabler for developing these capabilities that can then be delivered into the operational environment, whether it is Earth observation or space science, for exploitation and for delivering services and products that will benefit the South African community and the African community in large. Then we'll go to our flagship project, the EOSAT-1 Satellite Development Program. We'll look at the optical test frame that we are building. We look at the concurrent design engineering facility. We look at the HOTEC assembly integration and test facility upgrade project. We look at the Paardefontein radiometric calibration site that we are also upgrading. We look at some of the technology development projects and our future missions. Our space engineering program is charged with the coordinated development and operation of satellite systems, sensors, and subsystems. The state-of-the-art assembly integration and test services, and also for an environment that is conducive to enhance the competitiveness of the industry, and for the development of human capital in space engineering, basically to develop the space engineering industry in South Africa, mainly the satellite-built industry. In terms of the strategic framework, what we look at is space missions, Earth observation missions, science mission, experimental missions, communications, and human capital development. In terms of industry development, we look at technology development and management. We look at development of center of competencies, innovation platforms, and also entering into local and international partnerships. And facilities is the AIT facilities at HOTEC, and the calibration and validation facilities that are required, both pre- and post-flight calibration. Now, when we look at our broad mandate in terms of what we are supposed to satisfy in terms of the broad South African user requirements, we have a broad-based user in South Africa, mainly comprising of government departments and also includes the private sector. So it's both Earth observation users, both for navigation and positioning, as our CEO said, communication, and there are also space exploration requirements. But if you look at this, it both cuts across environmental and resource management, health and safety and security, innovation and economic growth. And there are different types of spatial resolutions that are needed. Some of them we are able to currently satisfy them, some of not. And this is our basis for going forward in terms of what missions we have to adopt. But we don't just use this, we go through a detailed user consultation program before we start a mission to ascertain exactly what are the user requirements and expectations before we execute a mission. Now, in terms of how we are organized in the space engineering department, in order for us to be able to do this, we have space system acquisition program management, space systems engineering that supports acquisition program management, and we also have space technology acquisition where we do our technology road mapping and initiate our technology projects. And these are in 4 different areas: spacecraft systems, where we look at large satellites, mini satellites, micro satellites, and nano satellites, including launch vehicles. We look at the control ground systems, where we look at ground stations, antennas, command and control systems, communication management systems, mission management systems, and ground support equipment. The same applies to data, ground systems, and applications, including also the required infrastructure in terms of facilities, whether they are for launch facilities or AAT facilities or launch calibration or laboratories that might be required for us to be able to achieve what we intend to do. Our flagship program, EOSAT-1. EOSAT-1 was supposed to be South Africa's first operational satellite. It's an observation mission. And it was designed for a 5-year useful lifetime with an extended life of 5 years on a sun-synchronous orbit, about 700 kilometers, with a total mass of 500 kilograms. We are looking to reduce this as we are, in the near future, we will be completing this satellite. This program was put on hold by the minister in 2018 due to funding constraints. But things have changed within the market. There's more availability of components that we need. Prices have gone down. So we will be doing a revision of the specification, and in the near future, we will be starting the project again so that we can complete it. We were at the preliminary design phase. We are just about to do a preliminary design review. Most of the components are at a very advanced stage of development. Some of them are already at a qualification stage. So, by the overall system, we are at a preliminary design stage. So soon as we start, we'll just consolidate, complete the preliminary design review, and start the detailed design review, then complete the critical design review. So we are looking to complete this within a period of 18 to 24 months. And then we will launch the satellite as we have promised the community. But definitely, we will be completing the project. 5 minutes. Okay. I'll have to go very quickly. I was just told I have 5 minutes. This is a blow-up view of the EOSAT-1 satellite. These are some of the development models of hardware. We have a flat set that is positioned at the Hotech AIT facility. That is the engineering model. These are some of the components that I'm showing here. And what we also constructed and built, this was a custom design that was done by Denel Dynamics Space Tech. Is the optical test frame for the testing of high-resolution optics. This is a structure that is based in one of the clean rooms at Hotech. It has a structural mass of 10 tons, and you can see the specification there. It has a height of 9 meters, 3 by 3. And these are the components of the optical test frame. I'm not going to go through all of them, but it has a seismic blaze, a seismic facility superstructure, interferometry test bench, an assembly test bench, a collimator test bench, a liquid mirror test bench, and optical test frame controller. We are about 95% complete, so we'll also be completing the O2F. And it will be required also for the completion of the EOSAT-1 satellite. What we also learned during the design of the EOSAT-1 satellite is that it took us a lot of time to come up with the architecture and to do proper feasibility studies in that regard. And we decided to come up with a concurrent design facility. We had a visit to ESA, the European Space Agency, and the DLR, the German Space Agency. And what we learned, at the German Space Agency, they have a concurrent design facility, and at the European Space Agency, they have a concurrent engineering facility. So we wanted both. But the advantage with this system is you are able to bring all your subsystem engineers, all your program management staff, your project managers, your budget controllers, into one room, including the client, and do the design on the fly. So what you would normally do in 3 months, you are able to achieve in 2 weeks, and you are able to fully assess the feasibility of a mission and come up with a design architecture that you can contract. So this is a pilot project that we've built here in our Pretoria offices. We will be building a bigger one at the Hotech AIT facility, and they will be able to interconnect, whereby we are able to work with some staff, mainly the client based here in Pretoria, and the engineers being there in Hotech, at the Hotech facility. These are some of the benefits that you can see there. I won't go through the process because I don't have lots of time to go through the concurrent engineering process. In terms of our AIT facility, this is the equipment that we currently have. 2 large thermal vacuum chambers, 1 large, 1 medium. We have a electromagnetic compatibility test facility. We have a vibration shaking facility, acoustic chamber, optical development and testing equipment, a 3-dimensional measurement facility, and a space material properties measurement facility. I won't go through the specifications of each because I don't have time, and I won't go into the description of why we have to test the satellite, but these tests are required for the environmental testing of the satellite because it has to go through a life cycle of in different environments. From the time you put it onto the launch vehicle, you experience this vibration. You have to test it to that vibration profile of the launch vehicle where you will be putting the satellite. So you have to design it to that to make sure that it withstands those vibrations that it will experience on the launch vehicle. Anyway, the launch vehicle provider will not allow you to put your satellite on the launch vehicle if you have not tested it to those tests that you are required to do. The anechoic chamber to do EMC tests, thermal vacuum to simulate the space environment, the collimator test bench for your testing and correction of your optical equipment, and the Paardefontein calibration side, because you have to calibrate your payload, your sensors pre-flight, but once the satellite is flying in orbit, you have to periodically calibrate it. This is the site that we'll be using to do post-flight calibration. We are looking at fully operationalizing it as part of developing our capabilities. These are some of our CubeSats that have been developed at CPUT as part of our human capital development, and also to build satellite build capability in the country using CubeSats. But these satellites have been launched, and some of them are currently in orbit and doing some work, specifically the Cube 2, which has an AIS payload to do automatic identification of ships in our economic exclusive zone. The current one is the M2M SAT, machine to machine. It's currently in development, and initially we had planned to launch it in the 4th quarter of 2022 or the 1st quarter of 2022-23. We have since experienced some challenges. We are working through them, and we are looking at launching them next year. This is the launch of the Phoenix 1D hybrid rocket that happened on the 14th of March. I guess you saw what was unveiled yesterday. This is a precursor work that was done for South Africa to arrive where it is. This is through the ASRI program at UKZN. Okay, and these are some of the technology programs that are currently running, and we are looking to transfer them from the DSI to SANSA. There's currently a steering committee that has been established to transfer this program. One of them is the K-line sensor, which has a wildfire identification, and we are also looking at improving it to do gunfire detection, including exact position. This will be very helpful when it comes to forensics. The other one is the synthetic aperture radar development, and of course the CubeSats program, including the launch capability establishment program. Future programs, the Space Infrastructure Hub, we are looking at Earth observation missions that will be starting soon. The user requirements have been completed. We are looking at starting the projects in the near future once we have finished developing the mission requirements, documents, and the technical requirements specification, which is the mission, which is the system specification. Space science mission for space weather. We are currently working on the user requirements. A SEA satellite mission. We are also looking at establishing electro-optic sensor center of competency. And our future missions will just be constellations, whether it's nanosatellites, whether it's microsatellites, whether it's mini satellites. We are no longer going to launch just one satellite. We'll just be launching missions, so that we can derive the full benefits of what these machines can do. And on that note, that's about it for me. Thank you.
Thank you, thank you, Mr. Makhalahadi, for sharing with us space infrastructure capability in South Africa, as well as our facilities within SANSA as a national space agency. Thank you very much for sharing the space engineering strategic framework, which entails missions, industry development, as well as human capital development. And it is a great thing that you are taking into cognizance the user requirements, because we cannot build these things without user requirements. We hope that we will fine-tune our building processes, making use of the concurrent engineering, as well as the system acquisition approaches. I thank you. Can you give our speaker a round of applause again? Ladies and gentlemen, that brings us to the end of our session yesterday, moderated by Kaiser Moroka, standing before you. I thank you. Maybe to do justice to Tebogo, maybe I can ask for 2 questions. Copying from Lulu. In the absence of, okay. Oh, there's one. Yes, sir.
Good morning. Nice talk, Debs.
Introduce yourself.
Oh, Lerato Shkwambana from
Yes, sir. I know.
SANSA.
Yes.
Yeah, so you spoke about the facilities at HOTEC, right? So my question is, will they be available for everyone to use within the space industry, or is it just meant for SANSA?
Copy it. Lerato, can you?
Okay, you mentioned the facilities, right? Like AIT,
Yes.
you mentioned the vibration facilities. So my question is, would people have access to the facilities if they want to develop their own satellite? Or is it just meant for
Okay,
just Sansa?
okay, you copied. Second question, you will answer both of them at once. The chairperson is behind me, the program director is behind me. I don't want to consume your time. So it's only that question. Going once. That mic is on. Is that the question? Are you preparing to ask question? Or is one of the recordings at the back? I'm looking at you, ma'am, at the back. All right. All right. No, there's one question. Tebogo, answer the question, and we are done. Thank you.
Thanks, Dr. Lerato, for your question. The facilities are not just available for SANSA or government. They are also available for South African private companies, including the African and international market, of course at a fee. Thank you.
Thank you.
Ladies and gentlemen, we are now officially moving to our very first session with a panel of speakers for today's program. As I will be introducing the moderator, I kindly request all the speakers for today to kindly step forward and take their seats. I am not the moderator for this session. For any questions or comments arising during the session, I kindly request that you log into the Slido platform, and the moderator will give the opportunity for Q&A at the end of the session. Ladies and gentlemen, the moderator for this session, the session for today is about sharing industry space, infrastructure, and operations. The moderator, she's the co-chair of Community of Practice on Satellite and Communications and Navigations of NEOS. She is also the founder of Astrophica, of Astrophica Technologies. Ladies and gentlemen, let us welcome on stage our moderator for the day, Ms. Jessie Ndaba.
Good morning, everyone, and all protocols observed. Forgive me if I'm not doing it in a right manner. A lot of people say engineers tend to be crazy people, their minds go this way, so yeah, please forgive me. And this month is the Women's Month, so I guess I can get away with a few glitches there and there. Thank you so much, Program Director. As we are having our panelists joining us, I would really love for us to be cognizant of the time, but in the meantime, I was sitting there thinking when Humbulani was giving his talk, Advocate Makapela asked if there are any comments or questions, and I reserved my comments because I was really hoping there is somebody in the house that will have some comments, and then I thought I will have mine, you know, when I'm talking. So before I even begin, thank you so much, Chief CEO, Chief Executive Officer. You must forgive me. I'm in the presence of brilliance and greatness. These guys sitting here next to me, my mentors, you know, from the day I started. So yeah, whenever I see them, yeah, it just takes me back. So yeah, Humbulani was actually one of the guys that supported our program, our internship program. Unfortunately, I don't see him here. He should have been here so that I can give that man his bells. He supported the internship program that was run by the Department of Science and Technology and the University of Stellenbosch and the private company called Sunspace and Information Systems. And I've always said, I'm actually a product of what can be produced if we work together and not in silos, because Dr. Morphe mentioned yesterday that South Africa has never had the budget, but we've always pushed and made things happen, and we have really done that. And a lot of people say, when you say your government has invested, why don't you have satellites? But we have these guys to tell us that indeed our government has invested in space, which is why we have these brilliant guys being here, and they've been here forever, and they survive through export. So I was going to start by the downstream or the imagery with Canis and Alex, but because I have to be cognizant of the fact that SANSA is government and they are funding our programs, therefore I will start with Dr. Eugene Avenant. My reason for wanting to start with Canis and Alex was precisely what Kaiser was talking about, that when we design these satellites, we need to understand what the challenges are so that we don't just design these satellites and have them placed in space and later try and find out what can be solved by those, but rather understand the challenges that we're facing and design these satellites based on the challenges that we're facing. But unfortunately, because I have to respect Dr. Eugene for being with us, I'm going to start with him. So Dr. Eugene is a chief engineer at Space Ops. He graduated at the University of Pretoria, so he has always been a Gauteng man. He has worked at CSIR, so CSIR is like a third home for him because SANSA is now his second home. He has worked for SAC, which was a Space Application Center. He was part of the team that established new ground segments, and later, when SANSA was established, SAC was placed under SANSA as SANSA Space Ops. And he heads a number of programs, one of which being SIH, that I believe a lot of people would want to hear about. Marcus Fontaine as well, he's a systems engineer for that. It excites me when I hear a kid in Khayelitsha talking about Marcus Fontaine because of the deep space missions that we are involved in. Ladies and gentlemen, please join me in welcoming Dr. Avenant.
Good morning. First of all, I know there's a number of academics in the audience, so I just like to correct the qualification. I am not a PhD. I'm just Mr. So let's just. But thank you for the compliment. Secondly, I find myself as the sole public sector representative on this panel. So I think there's a lot of anticipation about what we have to say today, especially around the SIH. And I hope the message that I bring is in line with the expectations of industry. I very much like the introduction we had from Brian this morning on the expectation of industry, and a lot of the stuff you're saying, I hope we can address here in terms of how we as SANSA would like to support our local industry. And it's not so much that we're trying to be good guys, it's literally the only way we're going to make things work in this country. So I'm not sure if my slide deck is up. I'm also very much aware that we very much behind schedule, so I'm going to talk fast. So as I always say, please listen fast as well. I'm going to run through a slide deck, but hopefully the message comes through. So if my slides are ready, I can start. I know they have them, they were up when you started your presentation, Brian. There we go. So, okay, so first, based on the topics of infrastructure and operations, I just quickly want to focus on some of the existing operational infrastructure we have within the Space Agency. I'm not sure if I need to ask for advancing the slides or if I have the capability of doing it myself. So if we can do, is it over there? Okay, let me take the podium rather. Fantastic. Okay, so some of our existing infrastructure, as many of you may know, so it stretches across the country, but also the region and even further afield. So starting at the top left, we have, as far afield as Antarctica, we have the Superdaan radio as operated by our space science unit. Also the instrumentation network, this is a small little subset. They actually have equipment distributed across not just the region, but also the entire continent of Africa, gathering the information that they require in terms of delivering their products and services around space weather, but also gathering the information they use for doing the academic work they do, the research. Of course, we have the facilities at Hartbeespoort, which I'll get into a little bit now, and then the Space Science Center in Hermanus. Okay, so the services we deliver at our at our ground station at Hartbeespoort is across the entire value chain of the space sector, starting with launch all the way through to end of life and deorbiting. And the model we've had is, over the years, is to closely collaborate with both public entities across the globe, so all the other agencies, but also private companies throughout the process. And it is proven to be a very successful model. We've created a ground station that is very much sustainable, and the word sustainable is going to come up a number of times. So everything that we need to do needs to be done in a sustainable way. We know that our fiscus is very much constrained, and if anything that we can do and any service that we can deliver is done in a commercially sustainable way, I think we more or less support our mandate, in one of the elements of our mandate. Looking at, I think, a number of presentations already made through this conference on the Space Weather Center, so another operational entity that also has a focus on delivering products and services, not just to the public sector, but also to the private sector, and then having very much a commercial focus as well. Okay, so SIH, everybody asking me about the SIH. So I'm, to some extent, the custodian of the SIH at this point in time within the South African National Space Agency. I just quickly wanted to step back and take the process of where we are with the SIH. I think a lot of, myself included, people, especially in the industry, feel a frustration on the seemingly the lack of progress. But just to give you an idea, so once you start engaging with government in terms of getting funding for a program, it is a bit of a process. Remember, we are all space sector people around here, but we are now competing with the people building schools, roads, and all sorts of other infrastructure for funding. And this is the first time Treasury has been engaged by people from the space sector to try and fund a large infrastructure project. So it's also a learning curve for them. So the journey started as far back as April of 2020 when we delivered a proposal called Space Data as a Service for Sustainable Development. At the time, it was maybe a bit optimistic or pushing in terms of creating a system that would be sustainable. And we went to the CITS Summit in June of 2020 trying to engage with financiers, not just funders. And as many of the people at the table in front sitting here would probably know, when you walk into a financier's office with your space project proposal, you get a number of very difficult questions. And as Brian also mentioned earlier, heritage is an important selling point when you go to a financier. So based on our initial proposal, a so-called strategic infrastructure project, SIP 22, was gazetted as early as October 2020. So it shows that our message was taken seriously at national government. So it's now a strategic priority for the country to support this project. But that doesn't mean you immediately get funded. So there's a whole process you need to go through before you actually get the funds in your bank account. Based on the feedback from the financiers, we went and looked at the business model for the SIH and decided to essentially split it into two. With the first phase looking towards a funding approach and the second phase towards a financing approach. In order to unlock funding from Treasury, we followed a process called the Budget Facility for Infrastructure. Within Treasury, there's a number of very specific steps you need to follow. And in May of 2022, we were ready with our primary submission with the support of our stakeholder, the DSI, and we submitted that. It takes quite a while, like I said, we're in competition with a number of other infrastructure projects for money, for being funded for our program. So in July of 22, we got our first round of feedback that identified a number of shortcomings in our business case, which we tried to address. We then submitted an updated response to all of these gaps identified, and then the final, sort of the formal assessment of our business case was delivered to us around November 23. This still, so at that evaluation phase, it was essentially, the SIH was essentially approved and a provisional allocation of funding was made. But this all hinged on a number of gaps identified in our business case, 6 primary gaps with 2 secondary gaps that we needed to address, some of them around the demand analysis. So the big focus on the evaluation of our business case was around the sustainability of the project. So will we be able to generate the sort of revenues that will make us bring in a business case with a positive return on investment over the period that we put out. The main, especially the main gap that they identified is the comprehensiveness of our cost-benefit analysis. So under some severe pressure, we were able to contract a cost-benefit analysis to the industry, which we then delivered in March of this year. And we are, we addressed the gaps by March of this year, and we delivered the cost-benefit analysis by the end of July. And we are now awaiting the final evaluation of that. Just a quick reminder on what the SIH is actually trying to achieve. So in the phase 1, I think it was already mentioned by the CEO and Tebogo before, we're looking at 2 space missions, one an Earth observation satellite and one a space weather satellite. We're looking at establishing additional ground segment capabilities, and that is in concert with the Maatjiesfontein, which I will also address a little bit later on. In terms of the data processing and product delivery, we're looking at expanding our current capabilities and establishing some new capabilities. And then the main thing, as was mentioned before, we are not going to sell data. That is not the business anymore. It's about selling solutions. One important aspect that we need to remind ourselves of is SANZA is not a big organization, and we have a whole space sector in this country. So the idea of our interspace infrastructure hub is to, as much as possible, engage with the local industry and develop these products and services together, and to come up with some innovative models in terms of leveraging this new IP in being sustainable, both in terms of the public sector and in terms of the private sector. But the main point of departure now, we know there's a lot of spacecraft already flying out there. There's already a lot of services, products and services being delivered in a commercial fashion. How do we think we're going to be making money in this one? So as sustainability is one of our core focuses for this program, it is not the only focus. And the 4 key reasons that I have to show every time is that how we're trying to also implement our mandate and ensure that we cover our mandate is these 4. So it's provision of public services and good, the strategic control of critical infrastructure, and the current geopolitical situation has just highlighted that in terms of how absolutely fluid international geopolitics is at the moment, and access to sensors that you might have this week might not be available next week. So having at least one sensor that you have full control over is probably geopolitically a good idea. And it also development of science skills, knowledge, intellectual property, and then research and development is an important aspect of SIH as well. And then, of course, going hand in hand with our industry, both up, mid, and downstream industry, so in order to support that industry as well. Also, as many of my colleagues, not my colleagues, the support network to the public sector, let's put it this way. We often hear that the space sector needs that heritage in order to unlock additional finance. And hopefully this project will allow at least some of that heritage to be built from a funding perspective rather than a financing perspective. Tebogo alluded to some of the analysis that's being done, the requirements. So this is just quickly in terms of the process. So we have now completed what we call the thematic Earth observation requirement, and also the first mission user requirement for the EO system. We have just recently, as this past week, started to work also on the space science thematic user requirement in order for us to move forward on that program. And in the middle, we have the common ground segment requirements that it's actually very far further along because of our work with NASA as well in terms of establishing the new ground station. This is a slightly different representation of the user requirement for the Earth observation as the one that Tebogo showed earlier. This is some of the key output from the thematic user requirement, which many of you in the audience, I think, was a part of in terms of the workshops. I hope that our Earth observation unit will have an opportunity in the near future to also confirm this user requirement with the community to ensure that our conclusions as best represent what the community wanted to. The main thing here is we're trying to build with the first space mission, the mission that essentially has the biggest bang for your buck. So we're looking at the priority one, and that has been devolved into a set of mission requirements that we would move forward. At the bottom there, so we're talking about phase one, which is a very modest approach. Phase two, then, we're looking at constellations. So some of the things you'll see in the thematic user requirement is that driving towards constellations is extremely important in terms of getting operational systems out there and addressing the real problems. So we're not just fixated on optical, we are also looking at SAR in the phase two of the SIH. Okay, quickly on our collaboration with NASA. As you know, NASA is going back to the moon. The old space race is back on again. Artemis 1 has already flown. Artemis 2 is essentially confirmed with the crew for the mission already selected. And where SANSA's involvement is going to happen is with Artemis 3, which is the first lander to go onto the moon. SANSA has been proven to be critical to the network that is required by NASA for this mission. And it's a big part of the underlying motivation for doing this ground station. And there are some extreme pressures on this program to deliver Artemis 3 in the timeframes that they want to do. There are a number of things that need to happen between now and then on the NASA side for this mission to fly when it's intended to fly, not least of which is SpaceX getting Starship to fly properly and not just be a really expensive firework. So just to quickly show where SANSA fits in, so we call the so-called LEGS, Lunar Exploration Gateway Stations. So the one in blue in the middle and the bottom is essentially confirmed. That is what we're working on. It is being funded by our stakeholder, the DSI, for the common infrastructure, and then from NASA's side for the mission-specific infrastructure. So we are on course to have that site ready. In yellow is what we call the commercial part of that system, where they need essentially a backup system or a parallel system to the public sector system, and already we're in negotiation to also establish the second system there. So we ended up in Matjiesfontein. Why Matjiesfontein? So we did a comprehensive study of the environment in South Africa and along with a number of parameters, it will be in the next slide, evaluated a number of sites in the country in terms of their suitability to this mission. Primary driver for the mission is the environmental conditions. We're going up in frequency, looking at Ka band and possible optical communications from the site. So we're looking at some of the drier areas in the country, which essentially limits us to the Northern Cape and the extreme parts of the Western Cape. The right-hand side is the current layout. So the bigger box is the farm boundary. The smaller box is 1 kilometer by 1 kilometer section that we have apportioned for space for the Matjiesfontein system. The bottom right is also co-location from Sarau for some of their scientific equipment. So why did we choose Matjiesfontein? So on a number of reasons. So primarily around, like I said, the climate conditions, but then it's hit the sweet spot on a number of parameters. It's close to the power backbone of the country. It's close to the internet backbone of the country. It's right on the N1. It's right next to a railway station. So it's really a lot of the stuff that would have cost us a lot of money to establish in any other place is already in place at Maatjiesfontein, and it helps us a lot to be able to establish this ground station in a far quicker way. So it's some shared interests, so I'm not going to harp on this one. Just this one, procurement. So a lot of our project is now driven around our procurement approach. Each one of those blocks there with a dot is an additional contract that needs to be placed out in the local industry. So it does show there is significant spend in our local industry, both, well, mostly in the construction industry. It's mostly a construction project. But the two main cost elements is, of course, the provisioning of power and the provisioning of backhaul connectivity to the site. Some of the things we've done out of necessity is essentially looked at a green implementation at the site, so looking at green buildings, low energy consumption, but then also having renewable power at the site. So, and the renewable power is there for two reasons. Of course, the primary ecological reason for using renewables. But secondly, we have a requirement of a 99.95% uptime at the site, and let's be honest with ourselves, if we relied on Eskom, we will never achieve that. So we're looking at both renewables and generators to ensure that we have the sort of reliability that we require. So in terms of our procurement strategy, just one of the things that we need to keep in mind is the targeting strategy. So we are cognizant of the fact that we are a public entity, and we need to ensure that we have broad-based participation in the procurement process as well. And as CEO already mentioned, we are very much involving the local community, both in the medium and long term. So in the medium term, just essentially contracting some of the elements of the construction to them, but in the long term, developing STEM education in the region and sourcing some of the operational staff that we're looking at employing towards 2026 at this site as well. So we're already working on the concept of operations of the site, having a clear idea of how we're going to be staffing and operating the site. So just my final slide on the benefits. So like I said, creating, I mean, just the fact that we're a little bit naughty, I suppose, but we're leveraging on the broad familiarity with the NASA brand. But this is real. It's not that we're stealing NASA's funder and using it for ourselves. We are really hand in pocket with NASA on this. We are a crucial aspect of the program, and we can actually use their brand identity also to bring a little bit light to our own public sector. So this is just a quick introduction. I hope it was quick. Let's give my other colleagues an opportunity also to present from their side. Thank you very much.
Thank you so much, Dr. Avenant. I promise to be as short as I am, but please, guys, do give us time, because we really have a lot to learn from our panelists. We have our African colleagues here joining us, so there's a lot that my panelists have to share in terms of how South Africa managed to grow the industry and even transform it, by the way. So Dr. Avenant, as you were presenting, it's actually good that I'm here, and Ms. Majaja as well, because we were not aware that the CBA has been submitted, right? Ms. Majaja also sits on the SANSA board as well from the DTIC, and earlier on I mentioned that working in silos is not going to work for us, and at the board meeting last time, we mentioned that SANSA has to get in touch with DTIC and work together with them, because there is a study that DTIC developed for the industry development, a policy framework. It would also really help for us as SANSA to look at that. Okay, now I'm wearing the SANSA cap as I'm saying as SANSA, to look at that so that whatever we do as SANSA, we know that we deliver on our mandates in terms of stimulating and supporting the industry. And I love the fact that you mentioned that, you know, the products that SANSA will be selling, and not just data, will be doing that in collaboration with the industry, because we believe that SANSA has to develop the IP and then push it out to the industry to commercialize, which is what the upstream has been doing, and they're doing it very well. And the upstream is well organized. Allow me, I promise not to be long, but allow me to just mention this. The upstream is so organized, and when the CE was talking, I know that aside he was saying, but Jesse, are we ready? And I said to him, remember, you're talking to the South Africans. We were part of the QB50 mission. A lot of people do not know this. 24 nations were part of that QB50 mission, and only 2 satellites out of the 24 nations that participated, only 2 satellites survived. And those 2 satellites are South African satellites. And how did we get it right? Because we worked together as an industry. So we are well organized. We know how to make something out of nothing as the space people. So before I get carried away, because whenever I'm talking about space, I get carried away, allow me to introduce Prof. C.S. Mostert. I did not even ask him for his bio, because he's one of the guys we call the godfathers of space in Africa, actually, because South Africa launched the first satellite in 1999. But Professor C.S. Mostert was part of the first satellite that was built, not launched, the ClaneSat. And there's another young man, Dr. Alan Nelson, as well, who was part of that ClaneSat satellite. And then the second satellite was the GreenSat. A lot of people do not know about this because that satellite was also not launched. But the first South African launch satellite was the Sunsat in 1999 by NASA. And then the second one was Sumbanila, which I was also a part of. So Professor C.S. Mostert, I met him when I joined SunSpace. He was one of the co-founders of SunSpace. SunSpace was a spin-off company from the University of Stellenbosch. He was one of the co-founders, and I believe he was the youngest of the shareholders, the co-founders. Later, he co-founded Space Commercial Services and Space Advisory Company. So a lot of us here are really colleagues or cousins, if I should put it that way, because we have all worked together. It's a very small sector, but yeah. Professor C.S. Mostert has contributed big time. He allowed us when Professor Rob van Zyl approached me when we were going to UK and asked us if, as Astrophica, we can take part in doing the AIT and the project management of the satellite. Professor C.S. Mostert could have said, Jesse, go your way, but he said, I need you to stay so that you can be, you know, your roots could grow stronger. And there aren't a lot of people that can do that. I know I'm taking a lot of time, but I had to mention this. So he has contributed big time in the growth of the industry and the transformation of the industry. Thank you so much, Professor Mostert. Ladies and gentlemen, please join me in welcoming Professor Mostert.
Good morning. Apologies for my voice. I left half of it at home. Yes, so I may address you as cousins and the rest of the audience. Yes, so I have seen the South African space technology programs evolve over the last more than 30 years now. And the one thing that is interesting is that the things which are formally started by government actually rarely are completed. Rarely. We heard about EOSat 1, we're going to restart. I heard it's going to be restarted to finish, but ClaneSat, the GreenSat were all official, fully funded, budgeted for programs. It's when Mboneni said it exquisitely yesterday. He said the programs which don't have a budget, they are the ones which are successful. And remember the times from 1992 to 1999 in South Africa. Everybody was holding their breath. We didn't know if it's going to work or not. No? Everything essentially came to a standstill. And Stellenbosch University, where I was, I'm tempted to get stuck in the past now, worked with a STRIP program. The DTIC always had this vision about supporting industry and university collaboration in South Africa. And together with a few key industry supporters and the STRIP program, we managed to build Sunset. Not because it was supported by any formal government structure. We could effectively complete the satellite because we did not have a budget, because the budget can be cut. But based on the success, and Brian said it eloquently, if you don't have a satellite in space, you can't sell a satellite. Based on that, we started Sun Space, building satellites, and the technology evolved. So Sunset was first generation, develop everything yourself, called vertically integrated, because you couldn't really buy anything from anybody else. The second decade was not much different. So we've developed some Mandela set that happened in a small room in a very special circumstances at the DST. Again, not a budgeted satellite, it just happened. And so Mandela said the second decade was just redoing the technology in a next generation that is more reliable, more powerful, more capable. And at the end of that phase, in the decade from around 2012, EOSat-1 was conceived based on the South African capability, but in the international industrial system, the market from around 2008, of course, the financial crash made a big impact, until in the order of around 2014, 2015, 2017, the international market was not really well established. But then something significant happened, and that is that there was standardization. Now, standardization, because before standardization, if you wanted something, you have to develop it, or you have to live with whatever somebody else thought it was good for you. But with standardization, and it happened in the CubeSat standard, in a very benign place, a 10 by 10 by 10 centimeter little satellite. Because it was standard, suddenly 10 more people could participate, 20 more people could participate, 100 more people could participate. And that essentially opened up the space market for everybody. Then, of course, the 1U became 2U and became the first satellite, NSat-1, that participated in the QB50 launch that Jesse just referred to, was a 2U cube satellite, 2.5 kilograms, size of a loaf of bread, and 31 meter ground spacing distance. Remarkable, absolutely remarkable. It opened my eyes to what CubeSats can actually do. Of course, they have constraints, but they are very capable. And around that time, the global market also opened. So from around 2016, 17, 18, we started looking at taking this standardized technology and see how it can be applied in generating operational data sets. Now, having one satellite, you heard Sansa speak about, they're not going to invest in satellites, they're going to invest in constellations. That is at the heart of it. So one satellite, two satellites maybe in a pair, one satellite optical, one satellite SAR, very high resolution. You can advertise, you can do disaster monitoring, and you can. And maybe that's enough for a country. So I'm looking at this talk from a country perspective. Because you can get all the data you like. Here's one of the vendors sitting in front of us. You can get all the very high resolution data you want, okay? Except when they switch it off, okay? So when you have one or two of your own very high capable satellites, and you interface that with a global supply of data, then as a country, maybe you've done enough. Maybe you've done enough. You have a very good program. The problem is, what do you do with your space engineers? Because if you look at South Africa's history in launching microsatellite-sized satellites, we launched one in 1999, okay? We launched one in 2009, okay? We didn't get to launch one in 2019, but what does the engineers do in the meantime? Now, you can put them into a government company, Space Tech, part of the NEL, state-owned enterprise, but it does this, so there's no contract friction at all. There shouldn't be any contract friction at all, but somehow it didn't work. So it's not so easy. So how does a country get to operational data sets and have your space engineers working all the time? Well, one answer is export. Look at the whole stage, export score, you can label them all. Even Eugene Avenant he said he's from the state, but he's in a part of SANSA that is just exporting. They're exporting launch support services. So export is one way to solve the problem. And that is absolutely fantastic. So what we do today, SES Space, some of you know that we were involved in a forced unbundling of our supply chain, internal supply chain. Some of you are beneficiaries of that. What we do today is we focus on space infrastructure. It's difficult, it's hard to build a satellite, but it's even hard to build a sustainable space program. Ask SANSA. Ask SANSA. They have been working now since 2010. It's now 2023, and they got the breakthrough with the SIH, but it might be the last breakthrough in their life. If they can't prove to Treasury that the investment being made in space infrastructure is valuable to the economy, they're not going to get the money again. And it's not peculiar to South Africa. If you look at NASA, NASA was mentioned a number of times. The amount of effort that NASA must go to make sure that the funders of with public money understand the value that they are providing, the amount of effort that NASA has to go to is out of this world. Because that is what it takes. It even had to create a committee for Earth observation, a group on Earth observation, GEOS. GEOS was created by the Americans to get enough lobby power to get the American government to give them money for operational satellites. The government was very happy to give them money for scientific satellites. But if you end the Landsat mission, let's say after Landsat 7 it's over, what have you achieved? There's multiple scientists in this audience who have built their careers on Earth observation satellite from Landsat. Now, if we stop it, because there's some other clients in America may argue there's better systems now. But if you stop it, you stop the baseline of operational data sets used on a global basis. So how does South Africa get it right to invest in programs that create operational data sets that the users will go to the government, all the users sitting in this audience, and say, guys, we don't care what else you cut. And there's lots of us who don't want to be, well, whose budgets we don't want to have cut. But this is essential. We need this operational data set provided by these satellites that South Africa is investing in. That is the heart of the problem that SANSA has to solve. And you have the answers. The first speaker yesterday from the Air Force was extremely eloquent in describing exactly what the right answer is. It's through collaboration of users. But collaboration of users through government departments contracting together for some system is nearly impossible. Nearly impossible. And I have known the Department of, I've got a different name now, Department of Communication, Department of Trade and Industry, Department of Science and Technology, now Innovation. I've known them for 20 years. I've interacted with them for 20 years. They have never come to the table in goodwill and resolve the matter of how do we actually work together to pool our interests and our users and our budgets to get into space. There's always a kerfuffle. Then the DTI is ahead, and then the DST is ahead, and then the DOC announces a geostationary satellite. So it is really difficult. It is really, really difficult. So what we bring to the table is to at least support it between countries. We cannot resolve interdepartmental relationships in any way possible. But what we can do is we can go to a number of countries and we can support them with their national space programs and combine the output. We've done it. It's called the African Resource Management Constellation. It's now, we celebrate this year 20 years of the African Resource Management Constellation. Can you believe it? It was conceived at a United Nations workshop by a lady who worked for us at the time, who's now a lecturer at Stellenbosch University in political science. And she came back from the workshop and said, but here's an opportunity. We can collaborate and create this. So what happened? Well, the user requirements were developed in the first 3 to 6 years, and then we realized, so there's all the space agencies and the space secretariats working together, including South Africa. And then we said, but this thing needs budget. Okay, so we said, well, let's go to our political masters. And we got the DSI and all the other 3 countries, Kenya, Algeria, and Nigeria, together in a big meeting in 2009 in Algiers, and they signed a multilateral agreement. Okay? So what happened? Well, it's interesting that Nigeria was already investing in a satellite with very similar capability. So they were actually just subscribing their satellite and getting a free ride in the constellation. Kenya had their budget for 2 years available, significant budget, but there was no organization to apply it. Okay? In South Africa, the technical partners, we had two projects, a payload project and a satellite bus project. The satellite bus project was Sumandila-Sat. So Sumandila-Sat was actually the bus for the South African ARMC. The other project was called MSMI. It was a multi-sensor, hyperspectral, and multispectral with Belgian collaboration. That was a project within the Innovation Fund. So on the technical side, the teams were developing and they were ready to deliver. And then one day, what happens when things are not institutionalized in government, like with the space agency, a new official arrived and this person said, this is very interesting. It's not going anywhere. Okay? And that's after with the previous official, we spent a good 2 years taking him to all the launch sites, which I won't mention now, and giving him a full understanding of what does it mean and what's the implications. And he went with us to some of these user requirement workshops with the other countries. So you need an institution to be able to see things through. Okay? So it's 20 years later. I know that Nigeria motivated their next budget based on the ARMC. I know EOSat-1 is motivated on South Africa's contribution to the ARM constellation. I know that Algeria put 2 satellites in space with the same specifications, motivated on that. I know that Kenya did it. So such a multilateral collaboration is good for getting budget, but it's not good for getting things done. Okay, so one can learn from the SKA. So what next? Well, with the impact of miniaturization and standardization and the cost of satellites coming down to the point where they are, unfortunately they're still not, somebody asked me, can I buy one? I gave them a price and I said, not today, thank you. It's still expensive in many ways. You can combine the ambition of SANSA representing South Africa in a number of ways into constellations. And that's essentially what we do. We started developing 2 constellations some time ago. The FleetSAR constellation, you'll see some of it at our stand. We started with that in 2018. Okay? And the numbers involved in FleetSAR is such that when you go to any financier in South Africa, and you mention these numbers, they ask you, do you know Elon Musk? Okay? And of course, Elon Musk is investing in American technology. He's not going to come here. But when we got to the IDC, they said, let's look at the numbers. Completely different response. Let's look at the numbers. And they're very excited. They're very excited to be part of investing in space infrastructure. But of course, they're a bank. After everything, they're a bank. Yeah? So we've been working with the IDC and the CSIR with payload suppliers to develop the project step by step, pre-feasibility study, bankable feasibility study, international investors. It's a long, you know, 2023, 2018, 5 years later. I think, and in the meantime, we had all of our own challenges. So FleetSAR is one way of doing it. Go for the big money and apply it. The other constellation we are developing is AgriSense. Now, I know that agriculture can be served in a multitude of ways. The EOS Sat-1 is also advertised under agriculture. So you wonder, how's this working? No? But the good thing about agriculture is there's never enough data. People don't really know. Especially if you get into Central Africa, there's too much clouds. We once worked with Colombia on an agricultural application. It turns out they have 2 cloud-free days in the growing season. So optical camera is not going to help you. In AgriSense, much smaller satellite, CubeSat 6U size. Well, it's with different phases. First phase is CubeSat. It's a 6U CubeSat. You can see the flight model structure at our stand. And in this case, we work with countries. It's a modest budget required to start their space programs around that. There's a lecture later today on that particular thing. So at the end of the day, space is to now where you can conceive from an application point of view. I mean, the Air Force is sitting here. I know that they have a multitude of problems that they must solve that's outside of the borders of South Africa. Space is perfect for that. So I'm really excited that the Air Force is in the room for the simple reason that if you go and look at these pie charts of how many satellites are launched, then you see, well, there's a lot of remote sensing satellites launched. But if you look at who pays the bill, you see that 76% comes from defense budgets. That makes the difference. They have the need to see beyond the borders. The rest of us have the need to see inside the border. Okay? Okay. So last comment is that having achieved 2 contracts last year, restarting, we are in the business of human capital development. And you can meet 2 of our interns at our stand because all the other engineers are employed. The South African space business is booming in the export market. So thank you very much. Talk to you again.
Thank you, Professor Mostert. I must remember to use your last name. We are so used to using first names. Our next speaker is Mr. James Barrington Brown. I still remember the first time he came this side to start New Space. We had a road show together with Sears, James and myself, just introducing this new JV to the industry. Because whenever we're talking about our sector, we always say we need our government to understand what we're doing so that we can complement each other and not find ourselves at loggerheads. So Mr. James Barrington Brown is one of the typical examples of what Mr. Brian Dean was talking about earlier on when he mentioned strategic partnerships that are very important, especially in the space sector, because in the developing nations, we are competing with the housing department and everyone. You know, when you're talking about space, people ask you, but there are no houses, when in fact they don't understand that the work that we do is in fact required so that the decision makers can make informed decisions. So James Barrington Brown is one of the successful guys in South Africa running New Space. I don't know how he did it, because we hear that engineers are very bad in sales, but yeah, for some reason he got it right. He's an engineer by profession, but yeah, he's a great sales guy as well. I think we have a number of companies in South Africa that would demonstrate that it is very important to form strategic partnerships so that we can sustain what we are doing. Like Brian mentioned earlier, because we also have a satellite space, but for now, welcome Mr. James Barrington Brown. Please, guys, join me.
Thanks, Jessie. Distinguished members from the Air Force and people from government, ladies and gentlemen. As I think many of you, were expecting a panel session, so I'm completely unprepared for this. So like what most CEOs do, they'll go back to their default status and rave about how great their company is. But I want to twist that into, this is a real success story for South Africa. If I can come here and I've got this great story, I literally did turn up at Cape Town Airport with 2 suitcases and an idea, and I've built a business since then. But if a single white male, aging, balding guy can come to South Africa, and an immigrant to that, and can build a successful business, then there's something special about South Africa. And I've heard about brain drain and things and people wanting to leave the country. I would say stay, and you need to encourage more people to come to South Africa and see the opportunities that are available here. Thanks, and yeah, I mean, I have the privilege of actually living here, you know, not by choice, not by birth, but actually by choice. So, New Space, sorry, I'll go into default mode. We're a tier 2 supplier, and what does that mean? It means that we're currently in a gold rush of space. There's a lot of money coming into space. A lot of people are seeing the value of space and services from space. And it's a bit like a gold rush, but the problem with the gold rush is some people find gold and some people don't. But the people who made money out of the gold rush were the people who supplied the picks and the shovels and the buckets and the hotels. So we're a supplier of guidance navigation equipment, and we supply to all the primes, and not quite all. There's 1 or 2 that we haven't got yet, but we're supplying to at least 100 different customers. This is all export. This is all outside of Africa, of which about 35 of those are what we call recurrent primes. So people who are building the constellations, whether it's for communications, Earth observation, SAR, navigation, science, they all need guidance, navigation, control. So we're really doing very well because we are supplying to all those different people. What does that mean in terms of results? We are coming up to our 10th anniversary, beginning of next year. We're about 90 people currently down in Somerset West. Our turnover this year is going to be about 200 million rand. But what does that mean in terms of societal benefit? Again, I've heard a lot of talk about downstream, and this is where you can benefit society, and this is absolutely critical. I'm an upstream guy, but it's not that we're not doing things. So I did a couple of sums, asked my accountant to do a couple of sums. The amount of tax that our company has paid in this coming up to 10 years, if you take the corporation tax and you take the PAYE, is equivalent to, drum roll, 120,000 monthly social grants. Yeah? So this is where private industry paying tax can really benefit society. Yes, we're not directly doing downstream services, but it matters, employing people, paying taxes. The other thing, we've generated about $500 million of foreign currency coming in, about 500 million rand. I mean, that's a big number. But what does that matter? Does that mean I can afford to buy a bigger sports car or go and buy a yacht? What that means is that the exchange rate is supported. The more exports you have, the stronger the rand becomes. If the rand is stronger, that reduces inflation. The inflation rate affects everybody in the country. So it's really important to push this industry message. It's not just we're having fun building space stuff. It actually makes a big difference to the economy. So I think if I've got a message, I want to talk about government partnership. I sometimes feel that I'm hearing government telling industry how to be successful, or thinking that they can do this and that will benefit industry. We've seen a few of the presentations, Space Innovation Hub. There has been some industry interaction, I won't deny that. But there are companies who have been really successful. I mean, there's ourselves, there's Samira, we heard from Dragonfly earlier. Come talk to us, say, how did we achieve these successes? Because if I was to give them one sentence of why New Space has been successful, it's because we really understand the market. We really understand our market. We know where to put our efforts, where not to put our efforts, where to have a partnership with someone which will increase our accessibility to the market, but we don't have to do it ourselves. Government also has to understand their customer. And their customer might be the armed forces, but typically the customer is Treasury. So how do you convince Treasury that space is worth spending on? And messages from industry like this: we are going to be paying social grants, we're going to be employing people, we're going to be exporting and supporting the revenue. This is the message the government needs to give to, SANSA needs to be giving to government. Likewise, when we travel, and I've traveled both with and without Space Agency, if Space Agency supports industry by saying, look how great our industry is, then industry is going to support SANSA and say, look how great SANSA is. They've been supporting us, they've been giving us in-orbit demonstrations, they've been supporting our technology development. There's a really big opportunity to partner between government and industry, and we need to find ways of doing it. And I haven't really got time to talk about the ways that I think that we can achieve that. But for there to be a point to my talk, I have just come back from Utah, which is the biggest small satellite conference on the planet. It's where at least 50% of our leads every year come from. It's where industry gathers together, they talk about the future, the way the market's going. And I've just got 3 key things that I took away from that. And unfortunately, this will contradict some of what we've already heard. Satellites are actually getting bigger. Everybody's talking about small satellites and CubeSats. There is evidential data that CubeSats themselves are getting bigger and microsats are getting bigger. And why is that? Is because as the launch cost comes down, you want to keep things balanced. You want your payload, your platform, your launch cost to all be about the same. You don't want to put an expensive satellite on a cheap launcher, or a cheap satellite on an expensive launcher. So it just makes sense. As the launch cost comes down, satellites are getting also cheaper, but they're getting bigger. Bigger is easier to put together. You can get bigger apertures, you can get bigger bandwidth. And for the extra little cost of making something bigger, you get a lot more performance. Following on from that, the feedback really is that CubeSats are fantastic for technology demonstration, they're fantastic for education, but when it comes to operation, they really are very severely limited. And as I say, that little extra cost you can pay to get a slightly bigger satellite. So again, I would push government and the users to look at slightly larger satellites. Up to now, CubeSats have been a little bit oversold that they can do anything. They can't, frankly. And the last one from that is, I've also been talking to some people here, is technology is changing all the time, and especially ground station. I know SANSA have a fantastic facility at Harderbeetshoek, and they're looking at Mikersfontein as well. I mean, one of the programs we're looking on is data relay. So what you're trying to do is get more and more data down to the ground, but the problem with the existing ground station systems is because of orbital dynamics, you only pass over the ground station certain times, and unfortunately when you're passing over that ground station, you are over your own territory, typically, if you have your own secure ground station. Whereas for security applications, you actually want to be looking at places where your ground stations aren't allowed to be. So what's happening now is people are putting up constellations of satellites which have laser links between them, so you can then downlink to anywhere on the planet, and satellites, instead of talking upwards to this laser link system rather than downwards to their ground station. That means in real time, you can get high bandwidth data and constant 24/7 command and control of your satellite. How would that change your application? How would that change your mission if it's from the forces, if you can see over the horizon in real time? So start thinking about some of the things as technology changes, what does that do in terms of user requirements? Because again, I'm worried that we're sort of dusting off user requirements from 2018. Yeah, a lot of things have changed since then, so we need to keep that refreshed all the time. And not just look at current user requirements, but see how the market is evolving. What are they going to look like in 3 or 4 years? Because these space programs take a long time to implement. And typically, if you're trying to get data, how do you get data today rather than having to wait 3 or 4 years for your mission to get data later on? So I think, yeah, that's my 3 key messages. We have an exhibit very happy to talk, very happy to people come down to our facility in Somerset West and see what we're doing. But thank you very much for your time.
Thank you, Mr. Barrington-Brown. I need to get used to that. Ladies and gentlemen, before I introduce Francois, because on the programs, you have Dr. Robert van Zyl as one of the speakers, but he decided that he's going to ask Francois first to rather present. I'm not sure if he's also in the room because he's also one of the people that also have contributed big time in the industry growth. He gave us, as Astrofrica, our first commercial opportunity to work on the CubeSat. And we are forever grateful because like all the speakers have mentioned, that space heritage is very important. And for us, we had our experience as engineers, but not as business people. And it was easy for people to say, Jess and Khaled may be good engineers, but are they good business people? And for Rob van Zyl to have taken that risk to say, let me give this to an opportunity to do the AIT and the project management, it really means a lot to us. Let me introduce Francois Visser. I mentioned that the industry is very small, therefore we call each other cousins, but Francois Visser is really more like a brother because we've always been working together. Francois Visser is an AAC South Africa technical director. Previously, he was a chief engineer at CPUT. He has also worked with me at SAS, Space Commercial Services. The first time I met him, we were at Sunspace, and I have to mention that it is through people like Francois Visser that, we've journeyed through. It was intimidating for a Sowetan girl coming into the space industry, leaving Soweto, coming to Stellenbosch. But having people like Francois, who you knew that you could go to whenever there was something that you didn't understand, because in space we cannot tolerate mistakes, because once the satellite has been launched, you cannot go up and fix it. So, for the other engineers, it was difficult for them to allow us to be hands-on. But yeah, Francois Visser held us by hand. And he's also, he's very humble. He won't say this, so I will have to say it. He's one of the giants in satellite comms technology. And he's the only engineer in South Africa that has worked on all the launched satellites from the Sunset, because we were not a part of that. I am young, he's older than me. That shows, ne? Yeah, so, yeah. Francois, you have the floor.
Good afternoon, ladies and gentlemen. Jessie just reminded me how old I've become, becoming part of the furniture. So I'm with AAC Space Africa. We're part of a group of the AAC Clyde Space Group, international group. You can see there on the map. There are 6 companies in the group. We're the 6th, the newest company. Actually, tomorrow will be my second year anniversary with AAC Space Africa. So our contribution to the group is, and our focus area within the group is RF systems for space, software-defined radio payloads, anything RF and communications related. So just quickly, the group by numbers, there's about 180 employees globally across the 6 sites. We have just grown in the last 2 years to 10 people, hoping to add some more team members by the end of the year. 32 missions launched. Those that reached orbit are all 100% functional, so 100% success rate there. there's a number of divisions in the company. The group sort of grew organically from the beginning with space products and components. And with the merger of Clyde Space and AAC Microtech, the group started creating space missions, and the drive now is towards space data as a service to deliver timely and high-quality data from space directly to clients. So my talk will be going about how we intend to support that vision, supply space data as a service. So the group is quite vertically integrated. We endeavor to produce our own parts, build our own missions, launch them, operate them, and then also produce the data as finished data products. So just a quick slide about our team. We're 10 team members now. Among us, we've taken part in almost all the South African space missions so far. There's a list there, and a number of international missions as well. I was two of us were Sunsat team members back in the 90s. So why the interest in very small satellites? So as you can see here, over the last decade, the CubeSat market has grown a lot. I want to touch on something that James said. Launch costs have come down tremendously. There's been a lot of standardization in the market, and with this, a lot more component producers, a lot more companies that produce components and spacecraft, the barrier to entry has become lower, so more and more people have been able to enter this market and build CubeSats. We can also see here that the number of satellites that are successful has also grown, so the loss factor has also decreased over time. Satellites are becoming more reliable. The applications that CubeSats and other nanosatellites are used for, there's a lot of them. We've realized over the years that nanosatellites can do almost anything. Of course, there are some applications that are best left to larger satellites, of course. There's the limits of physics. But among these AAC Clyde Space, there's a number of areas of growth. Farming and forestry. 3 satellites launched to launch this year, another 4 by 2025. Maritime domain awareness is a big focus area, energy, safety at sea, and so forth. I'll be speaking more about this, make a case study of that. And then also weather and climate, with the acquisition of a number of companies by the group, especially AAC Omnisys in Sweden. The group has gained the ability to produce cutting-edge sensors, science sensors that can fly on cube satellites and microsatellites. So the move is towards constellations, because constellations give us better observational capability. And we increase the coverage of the Earth by reducing the revisit time over a specific area on the ground. So what we're trying to do is to make the production and the installation, the rolling out of constellations easier and cheaper. CubeSats have the advantage in numbers. It's obviously cheaper to build 50 CubeSats than 50 microsatellites. So it's recognized that there's value in launching constellations of CubeSat satellites. So there's the group has embarked on an endeavor to create scalable spacecraft architecture. Internally, we refer to it as SUSA. It's Scalable Ubiquitous Spacecraft Architecture. The goal here is to develop reusable spacecraft platforms that facilitate larger volume production. In the process, it helps to miniaturize the bus of the spacecraft, gives you more mass and volume budget for the payload, so more greater mission utility all round. Expansion is a project that's partly funded. It's co-funded by the European Space Agency. It's a 3-year project. The goal of this project is to develop an innovative satellite constellation service. We will be launching 10 spacecraft as part of the initial deployment, with the possibility of many more later. This project aims to deliver high-quality data in direct support of space data as a service business model. So there are some challenges in the deployment and the management of constellations that this project will try to address. Some of it is in automation and digitization during the design and production of subsystems for these spacecraft. The group has identified 3 focus areas that are essential to roll out successful constellations. The one is responsive propulsion, because you want to be able to maintain your constellation configuration. Articulated solar panels for maximizing power production. And the third one is inter-satellite links, to be able to transfer data between satellites and ultimately provide a capability to transmit data over the horizon down to your ground station. Hand in hand with the inter-satellite links, there is the data routing algorithms that have to be developed to accommodate the dynamic behavior of the constellation, and also electronically beam steerable antennas to be able to maximize link budgets between spacecraft. So a focus area that I want to single out here is maritime domain awareness, because we've been speaking about it for a long time. The group has been very active in maritime domain awareness. We've got several satellites. I think I might still have a slide about that here. But recently, something big happened. The High Seas Treaty was adopted by the United Nations. The goal is to increase the maritime protected areas around the world. And as it is, South Africa has 41 maritime protected areas, and one of the big problems there is illegal fishing. So it's a big challenge because a boat, the culprits are usually the smaller fishing trawlers. They're hard to find. It's a needle in a haystack problem. How do we solve this problem? So the first tool that we have is the automatic identification system. It's a terrestrial technology that was developed for tracking ships, navigation, prevent collisions between ships. It's a terrestrial technology, not necessarily developed for space, but that did not stop people trying to receive these signals from space. So here's an example of AAC Space Quest, our American branch. Their spacecraft, the Prize Sat-8. This is data. All the dots there are signals received from ships all over the globe, and this was on a single day back in 2022. So from AIS data, you can learn a lot. Every ship over a certain tonnage has to transmit an AIS signal, and embedded in that signal is a lot of information like the ship's identification, the location, of course, speed, and heading, and so forth, and several others. So we can identify ships that have the AIS transponders turned on. But of course, there are some of those that don't turn it on. In addition to this, the next generation AIS, the VHF Data Exchange Service, this is essentially AIS 2.0. We can use VDES as a secure VHF data transmission system between vessels and shore stations to communicate tactical environment of known vessels. And this will help to identify dark targets that are not actively transmitting an AIS beacon. In addition to all of this, VDE SAT is a special component of VDES, which was specifically designed for spacecraft. It provides a much more reliable link between the ground and the spacecraft, especially between the ship and the spacecraft, and spacecraft to ship. So much more reliable communications, higher bit rates, larger bandwidths, and it opens up a lot of applications. So how do we find these dark vessels? The keywords here is listen, locate, and look. And we intend to support these functions with our platforms. As time goes on, we standardize more and more. I'll show you a bit later how we standardize our platforms. But there's a lot of emissions in the maritime domain that can be received from space, and we can use that to track and identify vessels, sort of create a digital identity, as you can see over there. So we listen with smart software-defined radio payloads. With some clever maths, we can also locate those using those signals that we receive from the spacecraft. And then finally, once you find those black target culprits, you can gather more information with high-resolution imagery. It's not only about finding the target, but gathering enough evidence in case a matter needs to be taken to court. So gathering evidence is important. So the two spacecraft that that the group has standardized on, these are based on existing spacecraft that have been launched and are successful, so they've got space heritage. We've created two classes of spacecraft. The EPIC Link, it's the EPIC series. The EPIC Link is optimized for communication, Internet of Things, machine-to-machine communication. The EPIC View is a spacecraft that's meant to carry high-resolution images, and the baseline imager for this is the Samira images. Spacecraft that we've launched to date is quite a number of AIS spacecraft that gather AIS data for various clients. And then the VDES missions are mostly future missions. There's a partnership between AAC, Clyde Space, Orbcom, and Saab, in which the group intend to develop a VDES satellite together. AAC Space Quest is developing a 4U AIS satellite in addition to those that they already have. And then as part of the expansion program, we want to fly an AIS payload. And for that, we will be using this S3C, Stone 3 Communications, their Prion VDS transceiver. What one can also do with the Epic Link, as I said, signal intelligence, you can listen to signals. We've recently won a contract from Kava Space in India to supply an Epic Link spacecraft, a 6U spacecraft. It's an in-orbit demonstrator mission. It's based on the Epic Link is based on the Horizon Amber IOD-3 platform. The goal of this spacecraft will be to monitor marine radar emissions as a first step. There will be future satellites, a constellation of spacecraft in which we will be able to listen to signals from VHF to 20 gigahertz. The spacecraft will use an advanced software-defined radio payload, looking like the one here on the screen that's flown on a recent mission. It's got a powerful radiation-hardened computing platform built in, so it's designed and built for space. And just finally, our Epic Link and Epic View maritime monitoring and security solutions are available to the Southern African region through Astrophica Technologies. We also provide ground stations and operation solutions. Depicted over here as a ground station that we delivered to Botswana International University of Science and Technology last year. It's built in a container, so you can load it on a truck and go and deliver it anywhere on the continent. I think that is it. Thank you very much.
Thank you, Mr. Fraser. So now you understand why I say I have a lot of cousins, but he is my brother because he welcomed me in the space and we're still working together even today. Oh, there is Alex. Okay. You will notice in the program that we've shuffled our presenters around. That's purely because we wanted to start on the downstream and then the midstream and then the upstream. But because we had to respect Dr. Avenant, since he's with us, we started with the midstream and then we decided to cover the upstream. And now we're going to touch on the Earth observation side of things. Canis is also, though, an upstream guy, I have to say, and the youngest in the panel. It's amazing what Canis has achieved in his young age. So Canis is also a cousin of mine because we worked together at SCS again, although he was on the other side of the building and I was on the other side. Canis is also a co-founder of Dragonfly. They are dragons. You heard from Brian when he was giving the lecture. So the name says it all. Canis is a systems engineer. And he's always Canis, always smiling. He's my cousin as well. So allow me to welcome him. He says his presentation is very short, but then I said to him, your presentation is more interesting because it has pictures. People are tired of us talking space. They want to see what exactly are we providing with what we're talking about. So join me in welcoming him. He's actually younger than me as well.
So I'm Canis Veet from Dragonfly Aerospace, and I'd like to thank Lieutenant General Mbambu who kindly briefly introduced us yesterday. I feel honored to be grouped together with a panel of chiefs, chairmen, and managers. When I initially thought this would be more of a technical session, So I hope you bear with more my technical side of the presentation. So I was privileged to have an excellent technical team, which I could lead as spacecraft system engineer for the EOS Sat-1 mission. So I'll start with a brief overview of the infrastructure. We have a Dragonfly, and then move on to the production and operations of EOS Sat-1. So in the picture there, you can see we've got a 3,000 square meter facility with a total of 1,000 square meters of clean rooms. So we've got development labs, mechanical workshops, a flight model bonded store, solder, manufacturing, and rework areas. So our manufacturing, assembling, and testing areas you can see there are all environmentally controlled. The satellite assembly clean room, which I'm part of the satellite side of our business, are ISO 8 controlled and supports up to the building of 16 satellites per year. Our optical assembly clean rooms are ISO 7 controlled, and then we've got ISO 6 flow cabinets used for imager focal plane assemblies. Sorry, this thing keeps sliding now. Our environmental testing facilities, so we had to invest quite a bit installing our own facilities because there were no big enough working facilities available. So we have a small TVC, which are typically used for the components. The TVC goes down to 10 to the minus 5 millibar, goes from minus 40 to about 80 degrees, and then the size is about 1.3 to meters long and 0.75 meter diameter. So you can see there in the right bottom corner our environmental testing facility. And next to it is the large TVC. This is for full satellite systems. The length is 2.8 meters and diameter of about 1.78 meters. And then we've got a state-of-the-art Brill & Kjaer 80 kilonewton shaker. So maybe just the pictures there on the right, that's the satellite assembly facility. That's a high bay area with a 10-ton crane for deployables, SAR satellites, and then the left bottom one is our optical assembly facility. So this slide, I thought I'll spare you the text and just talk about EOSat production. So we started designing EOSat-1 the 6th of January 2020. And I actually got a reminder yesterday on my phone from a year ago, and this was the photo on the top left that I took 30th of August last year. So that day we concluded, we installed all the components, we had the payload harnesses we had to connect and install the solar panels. So following the final integration, we did environmental testing. You see the satellite there on the shaker. As mentioned previously, there are quite a few tests we need to do: shock tests, sign burst tests, sign signature tests, random tests. And then for the satellite, we also need to provide mass property measurements to the launcher, and it's also needed for controlling the satellite. So you can see the third picture there on the top. We built a frame where we would swing the satellite in. Oh, sorry. Sorry, this is one of the pictures. So the first one is the assembly one, the second one is on the shaker, the third one is we had to swing the satellite. We started one Friday afternoon at 3 and we just carried on until about 10 o'clock at night. It was a lot of fun. We had to swing it at about 9 orientations, and yeah, we had to be very careful. So the fourth picture there is in SpaceX's payload assembly facility in Florida. The container you can see there, we designed for the satellite to be transported in, and then we use it also as an assembly container, and then also we had to tilt it horizontally, so to mount it to the satellite ESPA. So you can see that bottom left one, it was tilted horizontally, and it took its first flight. We had to go over a 50 stack Starlink, or close next to a 50 stack Starlink, so it was quite nerve-wracking. But the satellite, yeah, it took its first flight. This next picture, you can see the launch. Brian was fortunate to actually be there with the launch. It was about 2 weeks after we mated it with the SpaceX launcher, and then that afternoon it released from the Falcon 9 rocket. Maybe just, so that morning of the launch, I got woken up with my wife at 4 o'clock, and she said, I'm going into labor. And I said, no, please. You'll be fine. It's only due in 3 days. And I went back to sleep. And at 6 o'clock, she woke me up with bags packed and everything organized. At 9 o'clock, we had our third child born. So, yeah. Luckily, she made it a quick affair, so I could still attend the launch party the afternoon. Yeah.
The baby's named after the Lord.
Unfortunately not. After releasing, we went into the LEOP. So LEOP stands for Launch and Early Operations and Commissioning Phases. The Launch and Early Operations consist of getting healthy data from the satellite, getting orientation, and then doing first calibration of the magnetometers. So the first 24 hours was quite stressful. We couldn't get communication with the satellite. It ended up, we were very lucky. It was just the order of commands we sent to our ground station that was swapped around. So because we did infinitesimal testing of that, communication link, so yeah. So then our mission control software takes over. Our mission control software during our commissioning phase, which took 3 months, we developed to be fully autonomous, the automated functions, so there's no operator intervention, except at the moment for scheduling images. So scheduling the images can either be done through a GUI or API from our client, and the rest of the functions are all automated. This includes generating parameters for the various tasks, which includes ground tracking, imaging, maintenance, payload data downloading. So it handles all of that. Then it also does, while we have an overpass, we have 18 overpasses a day. So EOSat-1, the orbit is about 15.1 overpasses a day, orbits a day. So in some orbits we have more than one overpass, it's fantastic. Previous satellites I worked on, we only had like 2, maybe 3 overpasses, if you're lucky 4, but then they're very low elevation. So having 18 overpasses, high elevation, full contact, super fast download, it's really next level working with that. So the MCS also does the ground station management. We've got 4 ground stations we work with. One of them is Hartbeespoort. Then we work with Awarua, New Zealand, Punta Arenas in Chile, and then Svalbard in Norway. So the Norway ground station is really nice. We get a contact session with that almost every day. And the other tasks it does is collecting whole orbit data. So that is typical, we call it a WAT, unpacking it and viewing it. We have about 10,000 parameters we log on the satellite, so there's no lack of data to analyze. So there you can see a picture on the bottom left of our MCS. The middle picture, we added a selfie camera. So in the first, I think, 3 weeks, we were able to take images, and we also turned on the selfie camera with, when it released from the launch vehicle, we got some debris in some of the images, which was quite cool. And then, so you can see there in the selfie camera, the front is the propulsion system. So we also had some images of the plume formed by the xenon electric propulsion system. And then on the right is some of the, so we're working with it's a new age MCS. The engineers themselves can build the dashboards. It is placing blocks, adding parameters to them, and the parameters just get populated. So it's really easy. So this is an example of our power system dashboard. Sorry, it's very small, but it shows the battery, the different cells, temperatures, levels, every cell, every strings levels, and then what's coming from the solar panels, which given to the bus, the state of the power system. Go to the next slide. So I just want to maybe give some information about EOS Sat1. So EOS Sat1 weighs about 180 kilograms, 180.5 last weight. So it was designed to emulate Sentinel-2 data. So it's got almost all the bands of Sentinel-2 data except the IR bands. It's got 11 spectral bands, 1 panchromatic and 10 multispectral. The native resolution of the panchromatic band is 1.4 meters, so it's almost 10 times, say 8 times better than Sentinel-2. I remember yesterday there were quite a few discussions around spatial resolution and needing better spatial resolution. This satellite was designed for precision agriculture, so you can track a tree a meter with a meter resolution. You can see cars very clearly. Unfortunately, I can't show pictures. I would have loved to show some pictures for you. Some more features of the satellite. So maybe to put the 180 kilograms into perspective, Sentinel-2 weighs about 1.18 tons, and it cost about $200 million to build, where EOS Sat1 is 180 kilograms, and it cost about $10 million to build, including most of the design. So, yeah, we're factors lower than what European government institutions could do. Maybe some other features of the satellite. I saw on Francois' slide deck, he didn't mention EOS Sat1 as part of the satellites they've been involved with. Francois worked with me for about a year and a half on the concept of this, we call it the HDRTX, or High Data Rate Transmitter. It eventually flew. It was actually a idea baby of ours back in 2017 already. It flew now. It reached a peak speed of 890 megabits per second. Its upgrade next year will reach 2.6 gigabits per second. So this is really crazy speeds. This is the maximum speed you can get out of the X-band. So the imaging capacity for EOS Sat1 is 1.4 million square kilometers per day. It does have cloud detection algorithms and histogram drawing from images and thumbnails, so we can filter the images before downloading them. What else is interesting there? So we've got xenon propulsion. The xenon propulsion is used to keep our RON. The RON is the time you cross the equator. This is important for our customers because for scientific data, you need the same viewing angles throughout the year and throughout its life. And then I'd just maybe like to say something about the control. So the control of the satellite is really interesting. The problem with CubeSats is they don't have enough inertia, so they're too small to be able to control accurately enough to be able to have continuous strips of data. You can set up a CubeSat to do a couple of second imaging with the right rate, but you can't have a closed loop control system as we have on this one. So this closed loop control system, we measured a 5 or slightly less than 5 millidegree per second accuracy. So to put that into perspective, that's about 10 centimeters change over 24 meters. And that's from 530 kilometers. So the jitter we experience on the satellite is extremely low. That helps to make the images a lot more crisper, MTF for the technical people. Yes, so the control of the satellite we're really proud of. And then the geolocation accuracy, we had a discussion yesterday with some of the image processing people here, and it's a new topic coming up. The better you can geolocate it, the faster they can actually have ground control points to locate the image, the faster the users can use it. So that's also a neat specification of ours. Okay, so Just move it on here. So the last one, the current status of the satellite, it's been, so this is this morning, it's been in orbit for 240 days. It's on its 3,642nd orbit. You can see a few points later there, that's about 145 million kilometers it's traveled. We've had more than 2,000 communication sessions with it. So we've only downloaded 513 images. We are only coming into the full production. We're scaling up the full production slowly. So we've taken just less than 3 million square kilometers of data. But just to maybe put that into perspective, we've scheduled, if there's another 650,000 square kilometers scheduled just for this coming week. And we'll double that every next week. So in about 5 weeks, we'll reach full capacity, and then next year this time we would have downloaded a petabyte of raw data. That is insane amount of raw data to process, and I'll leave it to the cloud people to do that. Yeah. Script run, 19,000, peak download speed, 890 megabits per second. Yeah, so that's the status of the satellites as well. So maybe just to mention one thing, our team has been a really amazing technical team, and they've been involved from GreenSat, Sunsat, Sumbandela, with most of the panelists here. But we were able to reliably design the components, so we've had anomalies, which we expect and we design for, but we haven't had one failure of anything, which I'm very grateful for, because this is this is the reason for me to stress, to keep it alive and keep it performing well. Yeah. So that's all from my side. Thanks.
I should now walk my talk. I said I'll be as short as I am, but yeah, we're running out of time. So please, colleagues, allow me to introduce Mr. Alex Fortescue. I was not aware that you have 25 years of experience. Yeah, he doesn't look it. So yeah, if you guys don't want to age, join space. So Alex is one of a rare breed, because he has 25 experience in working with both the government and the private sector. And it's very rare, because a lot of us, when we're talking to the government, we don't know what are the right words to say. So if you ever need to touch base with both the government and the private sector, Alex is your guy, which is no wonder why Max appointed him as the manager for the entire African continent. Let's welcome him.
Thank you very much. So I don't know if it's afternoon yet. This has been a really long session. I'm the last speaker, so I'll make it short and promise to make it short. And thank you for the compliments on not looking like I've had 25 years experience. Appreciate that. Made the trip worthwhile. So I'm with Maxar. For those of you that don't know Maxar, we were formerly Digital Globe. So we sort of, just to give you I'm going to skip the introduction, right? We're a world leader in space infrastructure and Earth intelligence. We actually build spacecraft now. There was a procurement of MDA, which is a space company that owned SSL, based in Palo Alto, with a 60-year manufacturing history that now belongs to Maxar. Seemingly quite a lot of Canadian companies sell themselves into America to sort of service the US military market. So we have that SSL capability now. I really want to talk about downstream here, not so much upstream. And we also operate one of the highest resolution constellations. So I just want to go back here. So, 60 years on orbit experience. You can read through that. Like I said, I don't want to go through too much detail on the upstream. The reason I put this slide in here, which is upstream, and we sell buses, is because when I mentioned our capability to the SANZA CEO sitting in front of us, he called me a mampara and said, we're only going to be buying local tech. So one of my colleagues over here, rest assured, we're not here to sell this kind of technology. So what is quite interesting is we're doing some really cool stuff. We're building the power propulsion element for the Artemis mission and also particularly for Psyche mission. That's a satellite that will orbit a metal asteroid in about 6 years, launching in a couple of months. And many other interesting missions on the left here. One of the missions that we are currently involved in is in-orbit servicing or in-orbit refueling of an American satellite, which I can't speak about too much. So our current constellation, some of you will remember QuickBird and Worldview. That was the stuff I was working with when I was studying. Obviously, that was sort of 1 meter. We're down to 30 centimeter now, 8-band. We're collecting about 3 million square kilometers a day. And we have learned very early on that this data needs to be accessible. So we've put about 130 petabytes onto the cloud. And that's all accessible, very expensive to host it. But we've learned that our customers need the data on hand. And so we've made it sort of available. That's one of the developments in the industry. We're also launching Worldview Legion. There have been a few delays. This was supposed to be launched about 2 years ago. Obviously, COVID had quite a big impact. Space is hard, as my colleagues over here know. We're building really sophisticated instruments that haven't been tested before, control moment gyros, etc. But what's interesting about the Legion constellation is its 30 centimeter 8-band class capability to increase our capacity of 3 million square kilometers a day with our current constellation to another 3 million square kilometers. So that's 6 million square kilometers a day. And uniquely, some of the Legion satellites will be flying in an inclined equatorial orbit, meaning that we get a 16-time revisit in a day close to the equator. So this is just a simulation here. I don't want to play the whole thing, but you kind of get the, this is over Riyadh, multiple images, 30 centimeter inside 1 day, which is unprecedented. We also have just signed an agreement with a SAR company called Umbra. They have a license to provide 13 centimeter resolution SAR. They published a 16 centimeter resolution SAR image, which you can see on the right-hand side. And the key thing about this technology is not only the resolution, because it really goes hand in hand with our customers that desperately need to have very high resolution data, but we often get clouds, particularly on the equatorial belt in Africa and other places. So it's the turnaround time of this data. So without a ground station, I was able to have a look at this image, which was acquired yesterday over the affected area in Tampa due to the hurricane. And interestingly enough, this was taken at 15:35 UTC. It was uploaded on LinkedIn, I think 2 hours later. So that included not only the download, but also the processing. So that's really, really quick turnaround times, really, really quick, or really, really solid revisit times that are sort of trending in the large commercial EO space. Just another example here, this is an LNG facility. I just wanted to show you an action example of a sort of, this is a 25 centimeter SAR with an optical image, really useful for change detection. If we need to provide change detection to customers, it doesn't look great here, but there are algorithms that manage this and, can supplement some of our optical image acquisitions. I also wanted to talk a little bit about the fact that because all our data is on the cloud, we're able to run AI ML. We're just completing a build of a 50 centimeter DTM, which is bare earth, and DSM, which is including buildings and trees. And because it's AI ML and on the cloud, we can at scale extract 3D buildings. And this is 50 centimeter with a 3 meter CE90 accuracy XYZ. So that's without any ground control points. Of course, we can get more accurate with ground control points, but the idea here is producing usable data at scale very, very quickly and ready for use. Just an example of the 3D building extract. We did a really cool partnership with a company called Black Shark. They're in the gaming industry. They create synthetic textures. And their company is currently working sort of with tourism. I can't speak too much about it, but certainly in some of the prime locations in South Africa in creating a virtual 3D environment that you can engage chatbots, and it's using this kind of technology as the base with the Black Shark that creates textures. So you would walk past your house. It wouldn't look like your house, but certainly the dimensions would look like your house, if I can explain it like that. What I think is really exciting about having access to these precision 3D products is it becomes a very good reference for geocoding of other data sets. So, Earth observation data is traditionally relied at scale anyway on shuttle radar topography mission 90-meter resolution DTM of the Earth that was flown in the late 90s or early 2000s on the shuttle. And, really that data is, of course, people tell me they've got a 30-meter version. It's really 90 meters. I don't care what anyone says. But we're now able to process and auto-rectify data to a 50-centimeter DTM on the fly. And I can't get this to play again, but what we're able to do then is take live feed drone information and auto-rectify it on the fly and overlay it onto a base, which is really quite exciting in terms of the defense intelligence space. Very last thing I want to speak about is the fact that we also signed an agreement with Aurora. There's a lot of obvious consolidation in the industry. They are a satellite-based wireless spectrum mapping, or have a wireless spectrum mapping capability with 2 satellites, and that's really cool for understanding how spectrum's being used illegally, legally. For example, the SKA, are people broadcasting in that radio quiet zone? The CEO mentioned it as a priority as well. So that's what's happening in the commercial space. Thank you very much for your time. Back to you. Thank you very much.
Thank you so much. I did mention when we started that we are going to be a bit long because we all want to hear of the capability that resides within the country, so that my chairman would know that the SIH is in good hands. My CEO, you can see that you did a very good job in investing and supporting in space. Your investment did not go to waste. I don't want to get into trouble with Advocate Makapela. She's my twin. We come from way back. She and I are joined by the hip, so I cannot afford to get into trouble with her. So I will kindly ask that the questions that have been posted, we rather have those whilst we're having lunch. If you're afraid to approach the person that you would like to speak to, come to any of us. We will hold you by hand and grab the person so that they can respond to your question. Yeah, I did wanted to mention that Ms. Makapela and I, and one of the gentlemen who flew all the way from Nigeria to attend this conference, we were actually the co-founders of the African Space Leadership Congress Youth Forum when we were still the youth, right? And today we're still working together. And there was a time when she and I would be sharing the stage. She would be talking about space law and I'd be talking about space engineering. So yeah, I cannot afford to get into trouble with you. So guys, please, all the questions that you have, we can have a discussion during lunch. Thank you.
Ladies and gentlemen, thank you so much for your patience and welcome to Major General Matebula. Thank you, sir, for your presence. At this stage, I would like to request Mr. Brian Dean to step forward, please, and also Mr. Debuho Mukhalakadi. This is the time that we're going to be handing over the gifts to our guest speakers. And thank you so much to our moderator, Ms. Jesindaba. And may the speakers please step forward. And ladies and gentlemen, this concludes our first session for the day. You are kindly requested to step out into the foyer area for tea, to the exhibition area, and we will be back at 12:45. Thank you.